Welcome to this video on graphing sine and cosine functions that have undergone horizontal translations. In this video, we're going to have a look at how we can graph this function here over a range of negative pi over 3 and pi over 3. So notice with this particular function, it's got an amplitude of 2, a period factor of 3, and it's got an epsilon, so a translation of positive pi over 3. So listing down all the values really quickly, we'll say a equals 2, n equals 3, and epsilon equals pi over 3. Alright, so the first thing I'm going to do with solving this question is I'm going to figure out what is the period in this case, and the period is going to be, so period is equal to 2 pi divided by the n, which is 3 in this case. So notice we're going to get a period of 2 pi over 3. Now the next step is I need to identify what function are we dealing with, and in this case it's a cosine function. So the general look of a cosine function is going to be something like this, where this point here, this point up here, this represents when cosine, so just a regular cosine function, would have an angle of 0 or 0 radians. But in this case, not only have we been period dilated, but we've got a shift of positive pi over 3. So recall, if we've got a positive shift or an epsilon that's positive, we're not going to shift to the right like we did in the last video, we're actually going to shift to the left. So what we can see is that over here, this is going to be pi over 3 and negative pi over 3, because we're shifted to the left because it's positive. Now, if we've got this cosine function starting at pi over 3, then what about after one period? Where will this cosine function, where will be the point of the repeat of this cosine function? And it's going to be the period, so the period here, plus negative pi over 3. So if I write that out, so one cycle is going to be negative pi over 3 plus 2 pi over 3. And in this case, notice it's a nice common denominator of 3. So we can simply say it's going to be pi over 3. So after one cycle, this function is going to be at pi over 3. Now, what we need to do is consider whereabouts is the axis and the y-axis. And this one, it's actually a really nice example to do because the axis is going to be right in between pi over 3 or negative pi over 3 and pi over 3. So I can simply draw it going straight down the middle like such. So this is going to be 0 radians, this is pi over 3 radians, and this is negative pi over 3 radians. Excellent. And what's really nice is notice that the starting point of this cosine and the ending point, it's the same as the specified domain here. So we don't actually have to modify any of this graphing so far. And the final step to finishing off this particular graph is we need to write the amplitude dilation. So notice that it's got a factor of a. So up here is going to be positive 2, and down here that's going to be negative 2. So this would be fairly satisfactory for graphing a period dilated, amplitude dilated, and horizontal shifted cosine function, but we can add one more feature, and we'll put in this feature here. So whereabouts does it cut? Well, it's going to cut between 0 radians and pi on 3 radians. So on the right hand side of the graph, it's going to intersect the t-axis at pi over 6 pi over 6 radians, and on the left side here it's going to intersect that negative pi over 6 radians. So this is an example of how we can plot or sketch a cosine function that is undergone both amplitude and period dilation as well as a horizontal translation.